In this video, we are going to solve some practice questions under linear motion. So I've got a number of questions with me here. The first question is saying, during a hard sneeze, your eyes might shut for 0.50 seconds. If you are driving a car at 90 kilometers per hour during such a sneeze, how far does the car move during that time? Okay. So we know that they're asking about distance. So what we're going to do is we know that speed is given by distance divided by time. Our goal is to find the distance. We're going to say that the distance is going to be speed times time. Now in this case, our speed is in kilometers per hour. We need to convert this from kilometers per hour to meters per second. Now converting this, we are going to use dimension analysis, where we're going to say in 90 kilometers there is 1 hour. Now in 1 kilometers there is 1000 meters. Okay, then again in 1 hour, how many seconds do we have? In 1 hour we have got 3600 seconds. So now we are going to cancel the kilometers, we're going to cancel the hour, we're going to remain with the meters per second. So we're going to say 90 times a 1000, then we divide it by a 3600, which is 25, meaning that our speed now is 25 meters per second. Now we can plug in the values here. So we're going to say distance is going to be, the speed now is 25 times the time is 0.50. So in this case 25 times 0.5, we're going to get a 12.5 meters. So in this case, this is the answer for this question. Okay, so let's go to the next question. The next question is saying, compute your average velocity in the following two cases. But A, you walk 73.2 meters at a speed of 1.22 meters per second, and then run 73.2 meters at a speed of 3.05 meters per second along the straight track. Okay, so we have two scenarios. Now we are trying to come up with the average velocity. What are we going to do? Okay, remember we do have the velocity and we do have the distance, but we don't have time. But remember, the average velocity in this case is going to be, the average velocity in this case is going to be the total distance. Okay, the total distance covered, let me put the distance total divided by the total time taken. Okay, now we don't have time, we need to find time. So let's first find time in each case. We have got the first case where we have got the distance, which is 73.2, and the speed which we have. So let's find the time for the first case. So the first case, we're going to say time is going to be, we know that speed, you can start from here, speed is given by distance divided by time, meaning that the time is going to be the distance divided by speed. So the first case is going to be, the distance is 73.2, the time or the speed is 1.22, meaning that the time in the first case is going to be 73.2 divided by 1.22. So this is giving me 60. So the first case we have got t is equal to 60. Okay, now the second one, we're going to use the same formula. Now we need to find the time again. So we're going to plug in the values where we have the distance, which is the same. We're talking about this case now. Okay, is 73.2. I'll divide it by the speed, which is 3.05. So I have got 73.2 divided by 3.05, which is giving me a 24. Okay, so the second time which we have is 24. Now, since we are saying that for us to find the average in this case, we are going to add. Okay, we are going to say the average velocity is going to be equal to, so we're going to say 73.2 plus 73.2 divided by 60 plus 24. So the average velocity will be equal to 73.2 plus 73.2. Then I divide this by, we know that 60 plus 24 is going to be 84. So I will divide this with 84. So this is giving me 1.74 meters per second. So this is our average velocity. So this is the answer for part A. Now part B is saying, let's first put this here. So the first time, let me just call T1. For the first we had this, then the one for the second T, it was 24 seconds, even here seconds. Now we can get rid of this. We know the displacement already. Okay, now part B is saying you walk for 1 minute at a speed of 1.22 meters per second and then run for 1 minute at 3.05 meters per second. Now in this case we have been given minutes, so we have to convert these minutes into what? Seconds. So we know that 1 minute there is 60 seconds, so we are going to use 60 seconds. Now in this case we want to find the average velocity, but we don't have the displacement, so we need to find the distance. So speed is equal to distance over time. We want to find the distance. We're going to say distance is equal to speed times time. So the first scenario is going to be the speed. Since we have said that the first one, they are saying you walk 1 minute, so the speed in that case we've been given that is 1.22 times the time is 1 minute. So 1 times 60 is going to give us 60. So the first distance is going to be 1.22 times 60, which is going to be 73.2 meters. Okay, now we need to find the second one. So the second one is going to be the same formula. Distance is equal to speed times time. So distance will be equal to the speed. Now we have been told that it is 3.05 times the same 60 because it's 1 minute. So we're going to have 3.05 times 60, which is going to be 183 meters. So to find the average, in this case we're going to say the average speed or the average velocity is going to be the total distance. So we're going to have 183 plus 73.2. We divide it by the total time. So the total time is going to be, we have 60 plus 24. Okay. Oh, now in this case the total time we're talking about, the time which have been given is 60 plus 60 because it's 1 minute, and then we also have 1 minute here. So the total time in this case is going to be 120 because 60 plus 60, 120. So we're going to have 183 plus 73.2. I'll divide this one by 120. So I'm getting my average velocity to be equal to 2.135 meters per second. So this is my average velocity in this case. But now, since we have been, the time here it is in 2 decimal places. Okay, so we can leave our answer in 2 decimal places. We can say it is 2.14 meters per second. So that is going to be our average velocity. Now part C is saying graph X versus T for the both cases and indicate how the average velocity is found on the graph. So now in this case, let's start with the first case. So now let me get rid of this. Okay, I'll get rid of this. We need to put, this is the first case which we had, the time. Then the second one we have got the distance, which is 73.2. The second displacement, so I'll put d1, d2 is 183. Now let's graph. So let's start with the first case. Now the first case, we can see that this is what we're going to have. Okay, so we have got the x here, which is in this case, this x, we are talking about the displacement. Okay, so in this case, this is going to be in meters, then this is going to be in t, which is seconds. T will be in seconds. Now we have the first displacement, which have been told to say it is 73.2. So I'm going to put this part here to be 73.2. Now the next is also 73.2, but we have to add, we need to say 73.2. Let me just extend it a bit, so it will be somewhere there. Okay, that is our x. Now so it's going to be 73.2 plus 73.2 or times 2, which is going to be 146. So this point is going to be our 146.4, this point here. Now the time here, remember the first time is 60. Okay, so the first time here is going to be 60. We're going to put it here, say this is our 60, or I can put it here. This is going to be our 60. Now the next time is going to be 60 plus 24. Okay, which is going to be 84. So this is going to be our 84 seconds, meaning that the first time is going to start from, this is going to be our first graph. Okay, to reach there, then the next will be, so I'll get this graph to say from this point all the way to this point. Then the next graph is going to be 84 comma that one, which is going to be somewhere here. Okay, now to find the average, it's a straight line. Average is going to be, we're going to represent with a dotted line. So this is going to be our average velocity. So the dotted line shows us the what? The average velocity. Then the one which we have there, the solid one, it is the path which was being taken by this person. Okay, that is the first scenario. Now the second scenario, we're going to have this. We're going to have our graph here. Okay, we still have the x here. Then we're going to have the t, which is in seconds. So this is in meters. So we have got the first distance. In this case, we have found that the first displacement was 73, still 73.2. Next, I'm going to say 73.2 plus the second displacement. So the second displacement is this one. Okay, that is the second displacement. So we're going to say this second displacement which you have plus the first one, so that we see the what, the last point. So it's going to be plus 180, 182, or 183, which is going to give us 256.2. Okay, so we have this point which is 256.2. Now the time in this case, we have got 60 and 60. So we're going to say this point is going to be our 60. Next is going to be 120, because 60 plus 60 is going to be 120, meaning that the first point here is going to be this one. Okay, it's going to be this point here, but let me not put dotted here. So it's going to be this point here. The second point will be this one. Okay, so we're going to have the first point here, then the second point is going to be supposed to be somewhere here. Okay, then I'm going to put a straight line as well. So we need to have this curve now, this curve, then we have that other curve. Now to find the average speed in this case, we need to get a dotted line from this point all the way to the starting point. So that is going to be our average velocity. Yeah, so that is it for question 2. Let's see how we can do question 3. So question 3 is saying the position of an object moving along x-axis is given by x is equal to, so we have been given the x is equal to 3t minus 4t squared plus t to the power 3, where x is in meters and t is in seconds. Find the position of the object at the following values. T is equal to a is equal to 1. So it's just a matter of us plugging in where there is x, we plug in with what? With where there is t, we put 1. So it's going to be 1, 4, then 1 squared plus, we have got 1 to the power 3. So as we can see here, we're going to have 3 minus 4 is going to give us negative 1. Negative 1 plus 1 is going to give us 0. So the first part is 0. Okay, that would be the displacement. So the first displacement is x is equal to 0. Now what if we plug in 2? That is part B. If we put 2, it will be x is equal to 2 minus 4, 2 squared plus, we have 2, then we raise to the power 3. So x will be equal to, this is going to give us 6 minus, this is going to be 16 plus 8. Okay, so what will be our answer in this case? So our answer is going to be, if we do 16 minus 6 minus that one, we're going to get 10. Negative 10 plus 2, we're going to get a negative 2. So in this case, our answer is going to be negative 2. So the displacement is going to be negative 2 meters. So the second one is negative 2 meters. So what if we plug in, part C is saying 3, we need to plug in 3. So we're going to have 3 times 3, then 4, we have 3 squared plus 3 to the power 3. So this is going to give us, 9. 3 times 3 is 9. Then 9, we have got 9 times, this is going to be 9. We have 4, 9 times 4, which is 36. Then plus, what else do we have? We have 3 raised to the power 3. So 3 raised to the power 3 is 27. So we have our 27 here. So what is 9 minus 36 plus 27? So it's giving me 0. So this one is also giving us 0 meters, 0 meters. Next, they want us to plug in 4. So let's see if we plug in 4, what are we going to have? So x will be then 4 minus 4, I have 4 squared plus 4 to the power 3. So I'll have, this is going to give me 12. Next, this is going to give me 64 plus this is going to give me 64. So these two are going to give me 0. So I'll remain with 12. So my x in this case will be equal to 12 meters. Okay, that is it for part A, B, C, and D. Then now part E is saying, what is the object displacement between t is equal to 0 and t is equal to 4 seconds? So in short, it's the same as saying t is equal to 4. What is the displacement? So in this case, we have already found. So that one, when t is equal to 4, because we are going to say 4 minus 0, we're going to have 4. So when t is equal to 4, the displacement is 12. We have already found this. So part E is going to be, the displacement will be equal to 12 meters. Okay, then part EF is saying, what is the average velocity for the interval from t is equal to 2 to t is equal to 4? So in this case, when they ask this question in this scenario to say t is equal to 2 to t is equal to 4, it is totally different from the second question, where they gave us two cases where we were adding the displacement and then we were adding the time. But this one, we're starting from t is equal to 2 all the way to t is equal to 4, meaning that we need to do 2 minus 4 minus 2. Okay, So it is totally different from the second question where we were adding the time and we were adding the displacement. So in this case, to find the average speed, we're going to say the average speed is going to be the change in d, which is going to be the change in x divided by the change in t. So in this case, we're going to have the x2 minus x1, which is the same as x final minus x initial, t2 minus t1. That is going to be our average displacement in this case, our average velocity, sorry. Now we have the displacement. Okay, the displacement when t was equal, so remember this was when t was equal to 1, when t was equal to 2, when t was equal to 3, when t was equal to 4. So let's go ahead and find the average velocity in this case. So the average velocity is going to be, when t was equal to 4, what was the displacement? It was 12, minus when t was equal to 2, what was the average? So negative 2, so it's going to be negative 2. We divide it by, when t2 is 4 minus 2. So in this case, we're going to have 14 divided by 2. So our average velocity in this case is going to be 7 meters per second. Okay, so that is it for part F. Then part G is saying graph x versus t for from 0 all the way to 4 seconds. So now from here we can see that this is how our graph is going to look like. We're going to have the time, the x in this direction. Then we have, so let's have this. Because we've got the displacement which is negative, I'll start from here. Okay, so I have when t was equal to 0, when t is equal to 1, when t is equal to 2. Okay, when t is equal to 0, 1, 2, 3, 4. Okay, so we have got 1, 2, 3, 4. Now when t was equal to, this is starting from when t was equal to, so when t was equal to 0, meaning that the displacement is going to be 0. Okay, the displacement is going to be 0 here. So here I'm going to put in, because I've got the displacement which is what? Which is the displacement here in this case we have it is starting from 0. Okay, starting from 0, then it goes to negative 2. Okay, so it is going down. So here is our negative 2. Okay, now from here we move another step. So we're going to start from here to say when it was 1, it was 0. So we can put, say there is nothing that was happening. Then when it was 2, when time was 2, the displacement was what? The displacement was negative 2. So starting from this point, when it was starting from this point, then the time was what? Negative 2. This point here. Okay, so that is the 2 comma negative, that one. So that was our displacement in this case. Okay, now that was our displacement. Then next we can see that from this point it went direct to what? From this point it went direct to 12. So we need to say it's going to be, at first it came from here all the way to 0 when it was 3. So it started from here, again it went to what? When it was 3, it went there all the way to this point. Okay, then next it started from this point again going to 12. So we're going to have our 12 here. Okay, so we're going to have our 12 there. Then it's going to start from 4. When time was 4, then it was 12. So it's going to be somewhere here. So we can have our line from this point all the way to this point. Now to find the average velocity in this case, this is our graph. To find the average velocity, we are going to have the dotted line. So it's going to start from there, all the way to where it started from, this point. That is going to be our average velocity. Okay, so now in this case, this is the graph which we have, and those are the values which we have just come up with. Okay, so we do have question 4, which is saying at time t is equal to 0, apple 1 is dropped from a bridge onto the load, onto a loadway beneath the bridge. Somewhat later, apple 2 is thrown. So somewhat later is same as a second later. So a second later, apple 2 is thrown down from the same height. The figure below gives the vertical position y of the apple versus t during the falling until both apple have hit the loadway. The scaling is set by t is equal to 2 seconds. Okay, with approximately what speed is apple 2 thrown down. So in short, what it means here is the first apple was dropped when t was equal to 2. Now the second apple was dropped 1 second later, meaning that the original time which we are going to have in this time for us to have the same displacement is going to be, this time is going to be, we are going to say we are going to have t, we're going to have t2 minus t1 because we're going to have 2 times here. So in this case, we're going to say it was dropped 2 seconds later. Okay, it was dropped 2 seconds later, meaning I'm supposed to say t2 minus t1. So meaning that the first equation here, for me to find the displacement, I know that it was thrown when something is thrown from the top of the building, the initial velocity here is 0. Okay, so if the initial velocity is 0, then we can see that this formula is going to work. Okay, now they are saying that when it was reaching down here, the t was equal to, the ts was equal to 2. So first let's come up with an equation for the first apple. Okay, so for the first apple, we know that this d is going to be our h. It's the one we're trying to find. The initial velocity is 0, so this is going to be cancelled. We're going to have half, then 9.8 times t squared. Okay, now in this case we have the time, so we have got h is equal to half 9.8. The time for it to reach down here, it was 2 seconds, so we square it. So we can see that we're going to have 2 squared is 4 times 9.8, then divided by 2, which is 19.6. So this 19.6, it is in meters now. Now what we have to understand is that for these two, for apple 1 and apple 2 to move with the same distance, meaning that since apple 1, apple 2 delayed by a second, so for it to catch up to the first apple, we need to say the original time minus t2. So we're going to say, we're going to have the second equation where we're going to say, let me first put this h here, 19.6 meters. Now to come up with the equation for the second apple, we're going to say the distance is equal to v initial times t. Now in this case, plus half, we're going to have gt. Now in this case, we're trying to find this v, okay, because we don't know this v. Okay, so what we need to understand is that we are going to have, this is the same as so for us to make the displacement for h to be the same, then this is going to be true. We say h is going to be equal to v for the same v initial, open brackets. We need to say the time which we are going to be given. Okay, we need to say t1 minus t2. Now which time are we talking about here? It was delayed by a second. As you can see, the second apple, it was being thrown at least somewhere here, meaning that the time here, this point here, the time is 2 seconds. So we can see that we have got, from here we have got 1, 2, 3, 4, meaning that this point here was 1, meaning that each box represent what? This is 0.25, 0.25, 0.25, 0.25. So if you do 0.25 times 4, we are going to have 1, which is this point. At the same time, 0.25 1, and again from this point to this point is going to be 1. So 1 plus 1 is going to be 2, meaning that apple 2 was dropped here, so it's going to be 2 plus 0.25, which is going to be 2.25. Okay, meaning that the time for apple 2 is going to be 2.25. We need to do minus, so it's going to be t1. Let me just put it here. It's going to be t1 minus t2 minus t1, then plus half g. At the same time, this is going to be t2 minus t1, then we square it. Okay, so the height in this case, if we come up with this equation, meaning that the height is going to be the same. So in this case, the height now is 19.6 is going to be equal to the v initial. Okay, the v initial. We are trying to find the initial velocity which apple 2 was thrown with. Okay, that's why we are finding the initial velocity here. So it's going to be, we have this t2 is going to be 2.25 because this is the region where it landed, minus it was thrown 1 second later, so we're going to say minus 1, plus half 9.8. Here we're going to do the same, 2.25 minus 1, then we square it. So 19.6 is going to be equal to, we're going to say 2.25 minus 1, we're going to have 1.25 v initial, plus there we're going to have 2.25 minus 1, then we have to square it. Okay, the answer we have to square it. It's going to give us, it's giving me 1.5625. I do times 9.8. The answer I get time divided by 2. So I'm getting this point 7.66. 7.656, but I'm going to round it off and say 7.65, 7.66. So it's going to be 7.66. So our goal is to find the initial velocity. I'm going to shift this to the left hand side. This is going to give us 19.6 minus 7.66 is going to be 1.25 v initial. So now we can see that 19.6 minus 7.66, this is giving me 11.94. 11.94 has to be equal to 1.25 v initial. Now we can get rid of this. We can see that our 1.25 v initial will be equal to 11.94. Let's divide both sides by 1.25, even here by 1.25. So we can see that v initial will be equal to 11.94 divided by 1.25. So this is giving me 9.55 meters per second. So this is the initial velocity which was used to throw Boati or apple 2. So this is the answer for this question. So we have another question, which is question 5. So question 5 is saying a boat is dropped from a bridge under construction, falling 90 meters to the valley below the bridge. In how much time does it pass through the last 20 seconds of its fall? What is its speed? So they want the speed of the last 20% of the time. But B, when it begins, so they're saying how much time does it passes through when it begins that last 20% of its fall, and part C, when it reaches the valley beneath the bridge. Now we can come up with a free body diagram. So we know that we have got the distance in this case, which is 90 meters. Okay, we know that when it was being dropped, the initial velocity here is 0 meters per second. Now the last 20%, it is impossible for us to assume to say this is the last 20%, but we know that it is possible we can find the first 80%. Okay, so we need first to find the time. We need first to find the total time. Okay, if we find the total time, then we have to find the 80% of that, of 90 meters. After finding that 80%, then we're going to say the total time minus the one for 80%, then that is going to be the last 20%. Okay, what I mean here is we're going to use d is equal to v initial plus half gt squared. So we do know that this is going to be our h now is equal to, this is times t, so v initial times t plus half gt squared. So the h is 90. Then since this is going to give us 0, we're going to cancel that. We're going to have half. Since it is going down, it is going toward the gravity, g is positive. Okay, so I'm going to have 9.8 t squared. Now we are finding the total time it took for the boat to reach, the what? Beneath the what? The valley. Okay. Now we can see that this is going to give us 90 is going to be 4.9 t squared. We divide it by 4.9. We divide it by 4.9. So t squared will be equal to, we have 90 divided by 4.9, which is 18.36. So I'll just get the square root this side direct. So I'll say this number, the square root, which is 4. So the total time is giving me 4.285, which is the same as 4.29 seconds. Now you're going to have this t squared is equal to 90 divided by 4.9. So you know that you're going to have t is equal to the square root of 90 divided by 4.9. So when you get this, you are going to find this. So this is the total time. Now let's put it there. I'm going to put this total time this side here. So the total time is going to be 4.29 seconds. That is the total time. Now they want us to find the last 20%. So first we need to get the 80%. So if I get 80%, I know that what is 80 of 90? So we're going to have 80% divided by, a percent is always 100% times 90. What are we going to have? So we're going to have 80 divided by 100, okay, which is 0.8, then times 90. So I'm getting 72. So we need to find now the distance of 80% is going to be 72. Okay, so we're going to have h is going to be equal to 72. That is 80%. So we know that 100 minus 80 is 20. So that will be the last which we're going to have. So we're going to have, we are going to say h will be equal to v initial times t plus half gt squared. Now we want to find the time. We know that this is going to be still 0. So this one is going to be 72, is going to be equal to half. The time is the one we are trying to find. So we have 9.8, then we have t squared. So I know that this is going to give me 72 is equal to 4.9 t squared. Divide both sides by 4.9, 4.9. So t squared will be equal to 72 divided by 4.9. So I'll get the square root of 72 divided by 4.9. So what are we getting? So if I do 72 divided by 4.9, then I get the square root. I'm getting 3.83. So 3.83 seconds, it is the time when it was 80%. Meaning that for me to find the 20%, I need to say this is 100%. Okay, the one for the first part. So this is for 100%, this is for 80%. Meaning that I need to say 4.29, which is 100%, minus 3.83, meaning that is going to be my 20%. So my 20% in this case is going to be 4.29 minus 3.83, which is going to be 0.46 seconds. So the last 20% is the time is going to be 0.46 seconds. Now they're saying that we need to find the velocity. The velocity, what is the speed in this case when it was 80%? Oh, sorry, 20%, the last 20%, what is the speed? So we know that speed is equal to distance divided by time. Okay, so the last 20%, for us to find the distance, we know that the 80% was 72, meaning that we need to say 90 minus 72, that would be the 20%, which is going to give us 18. So 18 meters, that is going to be the distance when it was 20%, the last 20%. So it's the one which we're going to use. Okay, because the total distance here is 90 and the 80% of 90 is 72, meaning that the 20%, we need to say 90 minus 72, which is going to give us what? 18. So in this case 18 is going to be our what? Our displacement. Okay, so I'm going to say 18 divided by the time, which is 0.46. So in the last 20%, it's going to be 18 divided by 0.46, which is 39.13 seconds. So it's going to be 39.13 meters per second. That is going to be the speed. Then the question again is saying, when it begins that last 20% of 4, meaning that the first 20% in that case, when it begins now, meaning that in this case we want to find now the first 20%. Okay, so in this case it's going to be easy. We're going to say what is the 20% times this, then times a 90. Okay, so we're going to say what is the 20%. In this case is going to be 0.2. So it's going to be 0.2 0.2 times 90, which is going to be 18. Okay, so the first is going to be 18, the displacement is going to be 18, so they want us to find the time. Since the initial velocity is c0, we're going to have this. Okay, so we want to find the time, so we're going to have 18 is going to be, this is going to be 1 over 2 9.8 t squared. So this is going to give us 18 is equal to 4.9 times t squared. We divide it by 4.9, we divide it by 4.9. So our t will be equal to the square root of 18 divided by 4.9. So our t in the first, that is when it begins to 4. Okay, so meaning that in this case the time is going to be 18 divided by 4.9, so the square root of this one, 1.9. So 1.9 seconds, that will be our what? That will be our time. So the time when it begins to fall, the first 20%. Okay, now sometimes the question is saying when it begins that last 20%, so they want us to find the time. So what was the time when it begins falling that time? Meaning that in this case, if we take it to say the first 20 when it begins to fall, meaning the answer is 1.9. But when it begins that last 20 percent of 4, so meaning that the 20% when it was starting falling now from this point going down here, it is the same as finding the time, which is 80%. So the time in that case, we found that when it was 80%, we found that the time was 3.83. Okay, meaning that when it was falling from that point, the time was 8 point what? 8 point, or 3.83. Okay, then the last question is saying when it reaches the valley beneath the bridge. So this one they want to find the total time, and we have already found. So in this case, the first, or in short, the first answer we found was 0.46. Let me get rid of this. So the first answer we found was 0.46 seconds. Then the speed was, if I can remember very well, we found the speed to be 3 point, for this one we found the speed to be 3.39. It was 39.13 meters per second. Then now this question, when it begins that last 20%, when it was going down, meaning that it's going to be 3.83. But if they ask you to say the first 20% of falling, then the answer is going to be 1.9 seconds. Okay, so the second part B, the answer is this one. The fourth one, or the third one, which is when it reaches on the value, then the answer is going to be 4.92 seconds. Okay, so we have number 6, which is saying a key falls from the bridge that is 45 meters above the water. It falls directly into a model boat moving with a constant speed, that is 12 meters from the point of impact when the key is released. What is the speed of the boat? Now, this question, the key point here is here is our question 7, which is saying a draws patient spots a flower pot that sails first up and then down past an open window. The pot is in a view of a total of 0.5 seconds, and the top to bottom height of the window is 2 seconds. How high above the window top does the flower pot go? Now let's come up with a free body diagram. So here is going to be our window. So we have this. Here is our question 8. So the question is saying, how far does the learner whose velocity time graph is shown in the figure below travel in 16 seconds? The figure's vertical scaling is set by v is equal to 8 meters per second. So they are saying that the velocity at this point is 8 meters per second, meaning that if this part here is 8, meaning this part here is 4. Add this number 9. Two particles move along an x-axis. The position of particle 1 is given by x is equal to 6 t squared plus 3t plus 2, which is in meters per second, which is meters and seconds. So they're talking about the displacement is in meters, the time is in second. The acceleration of particle 2 is given by a is equal to negative 8t in meters per second squared. Okay, at t is equal to 0, its velocity is 20 meters per second. When the velocities of the particle match, what is their velocity? So this question is very interesting. So there's a bit of calculus which we have to apply here. So let's first have particle 1 here. Okay, we have number 10. So number 10 is saying a rock is shot vertically upward from the edge of the top of the top building. The rock reaches its maximum height above the top of the building 1.6 seconds after being shot. Then after barely missing the edge of the building, as it falls downward, the rock strikes the ground 6 seconds after it is launched. In SI units, part A, with what upward velocity is the rock shot? B, what maximum height above the top of the building is reached by the rock? But C, how tall is the building? Okay, so now let's first come up with a free body diagram. So you shoot something from the top of the building. Okay, so let's say this is the building. So you shoot it from here, so it goes up, then it reaches, it comes down here. Okay, so it was supposed to hit the top of the building, but it came direct to the ground. They are saying that the initial velocity we don't know. The time it took for it to reach at the maximum height from the edge here, it is 1.6 seconds. So we know that when it reaches at the maximum height, the final velocity is 0. Now in that case, we want to find the initial velocity.